Hello, myself Khushi Patel, roll number 45. Today I will give you a presentation about Introduction to Enzymes. In this presentation we learn about what enzymes are and what they do, structure of enzymes and how they work, lock and key model and induced fit model. So starting with what enzymes are and what they do. So enzymes are nothing but just it is like a catalyst. Catalyst is any substance that increases the rate of reaction without itself being consumed. So enzymes are a biological catalyst. Why? Because it speed up a biological reaction. The compound on which an enzyme act is a substance. So how they do that? Enzymes can break a single structure into small component or join two or more substrate molecules together. Like amino acids are joined to make proteins and starch is broken down to glucose. Many fruits contain enzymes like a pineapple. Some enzymes can increase the rate of chemical reaction by 10 raised to 12 times, like hydrolysis of a fat to carboxylic acid, and alcohol is extremely slow. But this reaction occurs speed because of enzymes. So enzymes are a biological catalyst. Now we study about the structure of enzymes. So enzymes are a linear chain of amino acids which give rise to a three-dimensional structure, primary structure. Enzymes are made up of amino acids which are linked together via amide bond in a linear chain. This is the picture of a primary structure. Now secondary structure. The hydrogen in the amino group and the oxygen in carboxylic group of each amino acid can bond with each other by means of a hydrogen bond. This means that the amino acid in same chain can interact with each other. Like in this picture, there is alpha helix and beta sheet is given. In the image above, the dotted line represented the hydrogen bond. There are two forms of beta sheet in last picture depending on the direction of a protein chain. Like if the direction alternative between every bond, it form an anti-parallel sheet. If it remains same, then it form a parallel sheet. This is given in the last picture. Now we come up to the tertiary structure. Tertiary structure is nothing but it is a three-dimensional structure. And here there is a red helix are a alpha helix and the blue arrows are a beta sheet. Now we can learn about the how they work. There is two type of work, the lock and key model, and the second one is a induced model. So first we learn about a lock and key model. There is an area on the enzyme called a active site. So this in this picture, this is a active site given. It has a very specific rigid shape that only one substrate will exactly fit into. This model explains the specificity of enzymes well. For a long time, this was the only theory of how enzymes work. The substrate shape must be compatible with the enzyme's active site in order to fit be react upon. The enzymes modified the substrate in the intentions the substrate is broken down and releasing two products. Just like a particular lock can be opened by a particular key, that enzymes can act on a particular substrate due to the specificity. So how this we learn about the lock and key model. Now we came up to the induced fit model. Induced fit model, the enzymes or the reactants change their shape slightly. The reactants become bound to enzymes by weak chemical bond. This binding can weaken bond within the reactants themselves, allowing the reaction to process more readily. In this picture, we can learn that two substrate molecules are drawn into the cleft of enzymes here, and the enzymes change the shape forcing substrate and molecule to combine. In this here we can say that and the resulting and the product is released by the enzymes which returns to its normal shape and ready to undergo more reaction. In the end, they come up to the normal shape. So this is about the induced feed model. Thank you so much for your valuable time. Thank you.